Okay, guys, another night of fun uh, electrical theory. So we're in a new chapter, electrical theory. The next chapter, which would be chapter 4, and we're going to talk about it a little bit. Has to do with three things. A piece of paper, you're going to draw a circle. Put a line through the circle, right in the middle, right dead in the middle of the circle. Okay, and then put a line up in the middle of that half up to the line. And then create your Ohm's law pie chart. E on the top, I on the left, R on the right. Then you're going to write P equals E times I. That's your Watt's law formula. P being watts, E being voltage, I being current. Okay, because current and voltage equals wattage. And that's your power. So we're not going to spend a whole lot of time on crazy stuff tonight, just on good stuff. So we're going to talk about Kirchhoff's law, we're going to talk about Ohm's law, and we're going to talk about Watt's law. Not a lot about Kirchhoff's law. Okay, so Kirchhoff states his rule was that in a parallel circuit goes like this: down, it's a square block, square comes in, comes out, right? Comes in, okay, and it has lines that are parallel, like parallel streets. So Kirchhoff states that the total amount of current flowing through a parallel circuit is equal to the sum to all of the amounts of current flowing through each path. So the total amount of current that flows in that circuit, obviously, is equal to the sum of all paths. The sum of all paths, it's a dumb law. Sum of all paths is equal to the sum of current coming in. Well, that's just, why didn't you just say that, right? Okay, so Kirchhoff's law states that the sum of all current coming in is equal to the sum of all current in all the paths. He also states that the sum of all voltage drops in a circuit is equal to the source voltage. So what that means is the source voltage, if it's 120, all voltage drops in that circuit will equal that 120. So whatever the voltage drops be in the circuit, that will all equal 120 in the end. Okay? Series circuit, we know what series circuits are, right? They go through one light, continue on through another light, continue on through another light. Where a parallel circuit goes and has lights on separate things. So the old school lights, one bulb, and they all go out. The new ones doesn't happen that way. So, all right. So another thing, can you use Ohm's law to find the value of each branch circuit in a parallel circuit? Sure you can. You want to find the value of each branch circuit in a parallel circuit. Well, we know what the voltage is, and we either know the current or we know the resistance, and with that we can plug it into Ohm's law pie chart and figure out each path. So let's say we got a resistor of 5, we've got a resistor of 10, and we've got a resistor of 20 in Ohm's law. We can take the 5, divide the 5 into 120. What's 5 into 120? 24. That says there's 24 amps of current flowing through that resistor. We take a 10 ohm resistor, okay? Turn it on. That 10 ohm resistor, 10 into 120 is 12. That means there's 12 ohms of current flowing through that resistor. Obviously, it's a twice as big a resistor, so half as much current. The larger the resistor, the less the current's going to flow through. And the third one is a 20 ohm resistor divided into 120 is 6, right? So we got 6 going through that one. So we want 24 down to 12 down to 6. Okay, so 6 ohms of current. Okay, so altogether, if we add all that current up, we've got 24, 12 is 36, and 6 is 42. That means there's 42 amps of current flowing through that circuit. So if we have 42 amps of current flowing through that circuit, we can divide 42 into, if we divide 42 into 120, that would give us approximately 2.5. And if we took and we multiplied 2.5 times 5, the resistance, 2.5. So if you took 2.5 of the 42 ohms in that circuit, put it in the ohms part on the Ohm's law chart, divide it into voltage, 42 is just about 2.5. It's probably like 2.4. All right. Or no. 42 into 120 would be about like 2.9. All right. So we got about 2.9. So now we take that 2.9 and multiply it to by the 5, and you get like 14.3 or something like that. So 14.3 volts is how much voltage drop you get through that first resistor, because we took the total no, it's it. We took the total, oh no, we take the total resistance. Yeah, right. I won't do this online. We'll have to do this on a board, but anyways, you get it. You figure out your total resistance, you divide your total resistance in, and you get your voltage, you get your total amperage, you multiply your total amperage times the resistance, times each individual resistor, and that will tell you what your voltage drop is. And in the end, your voltage drop should come out to whatever the voltage is in the circuit. Well, we have to do it on the board to be more accurate. What is the total resistance in a series circuit? So how do we figure out a series circuit? Series circuit, remember the formulas? R1 plus R2 plus R3. So in a series circuit, we have a 100, a 200, and a 300. So that adds up to what? 600. So our total ohms of resistance is 600 in a series circuit. In a parallel circuit, it's a little different because you got to divide 1 over R1, 1 over R2, 1 over R3, and figure out the bottom first and then divide it into the one on the top. Okay, so there is a figure here that you don't see. Anything that has a figure in it, I'm not going to give you. So we're going to skip question number 3. So question number 4, in a parallel circuit, the voltage across each path is equal to what? What is the voltage across each path equal to? Well, the voltage across each path is equaled, the voltage across each path is equal to the applied voltage. So whatever the voltage is coming in is equal to the voltage going down each path. This is just simple understanding of, whatever's in that line is going out that line. Now, resistance takes place at a time. So if it's a long enough circuit, a couple hundred feet long, you're going to get voltage drop at some point. Okay. This is going to be short. You just need to know a series circuit. You add up the resistors, the total number, you can divide into the voltage, that's your total current. Once you have your total current, if you multiply that times the resistor, that will tell you what your voltage drop is at that resistor. The parallel circuit, you got to do your formula a little different. Okay. Okay. So I think that's all we're going to do in this chapter. We're just going to make this chapter brief. So I'm going to ask you these questions now. This is probably the longest chapter we'll do. I'm going to ask you these questions, and you can just answer. All right. So question number 1: Kirchhoff's law state what law? Sorry, my bad. Which law states the total amount of current flowing through a parallel circuit is equal to the sum of the amounts of current flowing in each path? Is it Kirchhoff's current law, Kirchhoff's voltage law, parallel circuits, or series parallel circuits. Question number 2. Which law states the sum of all voltage drops in a circuit is equal to the source of voltage in the circuit? Kirchhoff's current law, Kirchhoff's voltage law, parallel circuits, or series parallel circuits. Number 3. What contains both series and a parallel current path? Kirchhoff's law, Kirchhoff's voltage law, parallel circuits, or series parallel circuits. Question number 4. What contains 2 or more parallel paths through which current can flow? Kirchhoff's law, Kirchhoff's voltage law, parallel circuits, or series circuits. Number 5. What contains only one path for current to flow? And you would know that. Parallel circuit or series circuit. Which one? Okay. Question number 6. True or false? You can use Ohm's law to find the power of each branch current in a parallel circuit. True or false? Question number 7. Find the total number resistance in a series circuit. You have 3 resistors in series of 100, 200, and 300. Is the answer A 10, B 150, C 200, D 600? Okay. And in a parallel circuit, the voltage across each path is equal to what? A, the total resistance times the path of current. B, the source voltage minus the path voltage. C, the path resistance times total current. Or D, the applied voltage. And I didn't really get to Watt's law, but just remember Watt's law is this. P equals E times I. So if you're ever trying to figure out wattage and how much wattage you have, multiply whatever your voltage is in the building, or the voltage source you're using. I shouldn't say in the building, but the voltage source. If it's a 110 lighting, then you multiply that 110 times however many lights you got on that circuit, and that's going to give you your wattage. If you know what your wattage is, like if you got 1,000 watts and it's a 120 volt thing, you divide your 1,000 watts by 120, and that's going to tell you how many amps you're using in the circuit, so you don't go over your 80% of whatever your breaker is. So if your breaker is a 20 amp breaker, you know you can get up to 16 amps on that breaker. You want to stay just shy of that 16. Because once it hits about 16.2, 16.3, the breaker's going to trip. And why does that breaker trip? Because the current creates heat. The heat activates the spring that's inside the breaker, and then the breaker trips. And then the spring cools down, you reset it. Alright guys, that was the longest chapter, 13 minutes and 18 seconds. Sorry about that. I'll try to keep them under 10. I will not have one on Friday. So this is Thursday. I will not have one on Friday, but I will not have one on Saturday, but I will again have one on Sunday. And I'm going to try to call you guys tomorrow. So try to pick up. It'll be sometime probably after 1 o'clock, because I know you guys sleep until 1 o'clock in the afternoon. So I will call you tomorrow and check in. All right? Okay, have a good night.